Hello, my third grade friends. Today we are working on lesson 25 of our Unit 5 fraction unit. And if we look at our objective for today, it is we're going to express whole number fractions on the number line when the unit interval is 1. Pop down to our I can statement. I can express whole number fractions on the number line when the unit interval is 1. So basically what we're talking about today is just whole numbers on the number line. So like 1 whole, 2 wholes, 3 wholes, 4 wholes, and so on. We're just going to show those on the number line. We're going to show what those look like when we write them as a fraction as well. Normally when we've had wholes, we just put like a big 1 or a big 2. But we'll also show what that actually looks like as a fraction on the number line. Okay, so your lesson for today is lesson 25 problem set. And I don't know about yours, but for whatever reason, for the lesson 25, it didn't print front to back. So I have the front and then it's stapled to this one right here. Maybe yours is front and back, but for whatever reason, mine didn't copy like that. But that's okay. Okay, so put your name and date on your paper and then show me that you're ready to roll. Okay, so number 1 says to label the following models as a fraction inside the dotted box. The first one has been done for you. Okay, so here we have one rectangle and the whole thing is shaded in. So they said that this equals 1 whole, which yes, we can see that, right? Next we have a whole, but it is broken up into how many equal parts? 1, 2, 3. So since there's a total of 3 parts, 3 of course is our denominator, because our denominator is always the number down on the bottom is the number of total pieces. There is 3 pieces shaded. So since there's 3 pieces shaded out of a total of 3 pieces, this is 3/3. And we can see that the whole thing is shaded. So we know that 3/3 equals 1 whole. So we're going to put a big 1 right there. Okay. Okay. Look at the next one. So the next one, we have a fraction greater than a whole, right? Because there's a whole shaded here, and then there's a half of 1 shaded over here. So this would be when we've practiced before fractions that are greater than 1 whole. So if we want to look how many pieces are shaded, there is 1, 2, 3 pieces shaded. So that's going to be my numerator, my number on top. Okay. And for my denominator, it's the total pieces in 1 whole. So here we don't want to get mixed up because you may be thinking, okay, for my denominator, it's 4 because there's 4 pieces. Were you thinking that? Okay. But we want to be careful with that because if you were thinking that it was 3/4, you don't need to draw this, but I just want to show you what this would look like. So if I were to put a 4 on the bottom, it would be 1 whole with 3 shaded in. And is that what this picture is showing? It's not. This would be 3/4 right here. 3/4 means that there's 1 whole divided into 4 pieces with 3 shaded in, and that's not what this picture is showing. This is showing 2 wholes. 1 whole is shaded and half of the other, so it would not be 3/4. What we want to do is that denominator would be the total amount in 1 whole. Do you remember that? So if we look at the 1 whole, how many total pieces are in 1 whole? 2. So this fraction to represent this right here would be 3/2 because there are 3 pieces shaded. And if we count them, these are halves, right? Go ahead and write 1/2 in each one of these. And then let's count them together. Okay, let's touch each one and count by halves. 1/2, 2 halves, 3 halves. So it might be helpful to just count them by halves, right? Okay, take a look at this one right here. What do you see in this picture? I see 3 rectangles. They're completely shaded. Are they split up? They're holes, right? So there are 3 pieces shaded out of 1. Okay, so remember that bottom number is the total in 1 whole. Same thing here. The 2 is a total in 1 whole. So this one is the total in one whole, and there's only one, right? So 3 over 1, and it also equals, we could put a big 3, okay? But to write it as a fraction, we would write 3 over 1, and if I see 3 over 1, I know that that is equal to 3 wholes, okay? So if I have a whole number of fractions, 3 over 1, because there are 3 shaded out of a total of 1, right? Each whole is only divided into 1. It's a whole. So that would be 3 over 1, and it would also be equal. I could write a big 3. But in fraction form, it would look like 3 over 1. All right, look at the next section here. Okay, so for the next section, how many pieces are shaded? 1, 2, 3, 4 are shaded, right? So that's my numerator. And what is my denominator? So my denominator is the total number of pieces in the whole, and there's 4 total pieces. And it is completely shaded, right? So that is equal to 1 whole. So I can make a big 1. So 4 over 4 is equal to 1 whole. Remember, when my numerator and denominator are the same, that means that it's equal to 1 whole. All right, look at the next one. How many total pieces are there? 1, 2, 3, 4. There's 4 total. Well, how many total pieces shaded? There's 4 total pieces shaded. That's what I was going for. I'm looking for that numerator. So the total number of pieces shaded, 1, 2, 3, 4 pieces shaded. And that bottom number is how many pieces, the total number of pieces in one whole. That's the difference. So I don't want to put a 4 because here's the difference. There are 4 total pieces. So if I put 4 over 4, that would be saying that this is the same thing as this. And is it? These pictures are different, very different. This is 1 whole, and this is 2 wholes. So I want to be very careful about that, boys and girls, okay? Because that bottom number would be the total number of pieces in just 1 whole, okay? And in 1 whole, how many total pieces are there? 2. So this would be 4 over 2, which means there are 4 pieces shaded out of a total of 2 pieces in the whole. And here's what we can do. So the cool thing to check, which I know we've done before, so to do a check and to see how many wholes, it says, what's 4 divided by 2? So you can say, how many times does 2 go into 4? 2, 4. It goes in twice. So I know, and this is a good check, that 4 halves is equal to 2 wholes. And do we have 2 wholes shaded here? We sure do, right? So even though they're divided up into halves, it's still 2 wholes. Let's write 1 half inside of each of these, and then we could also practice counting by halves, just like we did up there. Okay, so once you have the halves in there, let's touch each half and let's count. Okay, so you've got 1 half, 2 halves, 3 halves, 4 halves. So 4 halves is equal to 2 wholes. And I can see that I've got 1 whole and 2 wholes. I could also say 4 divided by 2 equals 2 as a way to check. Look at this one over here. What do we have here? We have 4 wholes, right? This is 1 whole, this is 1 whole, 1 whole, 1 whole. So how would I write 4 wholes as a fraction? I don't want to just put a big 4 first. I want to write it as in fraction form. So the total number of pieces shaded is 4. And how many pieces are in 1 whole? Just 1, right? So it would be 4 over 1. And that would be equal to 4 wholes. So we'll put a big 4 to represent 4 wholes. Okay. Also, what's 4 divided by 1? 4. So another way just to kind of check that in your head and just to get in the good practice of checking your work. Okay. So basically, anytime we have a fraction that's greater than a whole that's equal to some number of wholes, it's going to be the number of wholes over 1, right? Unless it's equal to 1 whole, then it would, like for 4/4, there's 4 pieces shaded and there's 4 pieces total. So that's a little bit different. But anytime we have like a number of wholes, it's going to be that number of wholes over 1. Here we had 3 wholes over 1 and so on. We'll practice more down here. All right, on the bottom, if you want to try, if you're feeling pretty good, you can pause and try this last one on your own, okay? All right, be sure to come back and check, and if you're with me, let's get going. So how many pieces are shaded? 1, 2, 3, 4, 5, 6 are shaded. And how many total pieces are there? There's 6 total pieces. So we have 6, 6, which we know is equal to 1 whole, right? That whole thing is shaded in. All right, and for this part right here, how many pieces are shaded? There's 1, 2, 3, 4, 5, 6 are shaded. And now here's the part, how many pieces are in one whole? Just one whole. There's 3 pieces in one whole, right? So this would be 6/3. What is 6/3 equal to? How many holes? 2 holes, right? Because I have this hole shaded in and this hole shaded in. So I'm going to put a big 2. And remember, I want my whole number to be the same size as my fraction. That just is a good kind of reminder to me that this is a whole number. Also, I can say 6 divided by 3. What is 6 divided by 3? 2. So you can say 3 goes into 6 2 times. 3, 6. Okay, look at this one right here. What do we see? We see a bunch of holes, right? So how many holes do we have? 1, 2, 3, 4, 5, 6. How would I write 6 holes as a fraction? Go ahead and write it down if you didn't already. So for 6 holes as a fraction, there's 6 holes, and there's only 1 in each hole. So it would be 6/1. Thumbs up if you had that. Good. And as a whole number, 6/1 is equal to a big 6 to represent that there's 6 holes there. I would really like you guys to make sure that you're writing the whole number. So equals, and then write that whole number right next to it. That's just a good visual for ourselves to of what it equals for a whole. Okay, go ahead and either flip it or turn the page if yours is like mine. Okay. So number 2 says to fill in the missing whole numbers in the boxes below the number line, rename the whole numbers as fractions in the boxes above the number line. So for 0 here, this is like, there isn't anything there. So we could just put 0/1 even, wouldn't really matter. Okay. Look at the next one. So this is 1 whole. So how would I write 1 whole as a fraction? I could write 1/1. Okay. How would I write 2 wholes as a fraction? 2/1, right? How would I write 3 wholes as a fraction? 3/1. 4 wholes as a fraction? 4/1. 5 wholes as a fraction? 5/1. And 6 wholes as a fraction? 6/1. Do you notice a pattern? Yes, anytime we have a whole number, we just put that fraction, or we put that number over 1, right? So rename the whole numbers as fractions in the boxes. So we did that. Good. So that was pretty easy peasy, right? Okay. And then this part down here. So some of them we need to rename the whole number with a fraction like we did up here. And some of them we just need to write the whole number down below. So 10/1. What is 10/1 equal to? It's just equal to 10 wholes, right? So we're just going to put a 10 right there. Okay. How about 11/1? What is 11/1 equal to as a whole number? Just 11, right? And again, you can do your check, boys and girls. What's 10 divided by 1? 10. This fraction bar is really just like a division bar too. So 10 divided by 1 is 10, and 11 divided by 1 is 11. Okay, here we have 12 wholes, and we want to write 12 wholes as a fraction. So what would that look like? 12/1, right? That would mean I would have 12 boxes, and they would all be completely shaded in. Okay, how would I write 13 wholes as a fraction? 13/1. If you want to pause and just finish up these last 3, you can do that, okay? All right, let's see how we did. What did you write for 14/1 as a whole number? Just a 14, right? How about 15? What did you write for 15 as a fraction? 15/1. And 16 as a fraction for 16 wholes. 16/1. Thumbs up, how'd you do? Good. All right, we are speeding through this today, guys. Look at number 3. So it says, explain the difference between these two fractions with words and pictures. So we have 2 over 1 and we have 2 over 2. What is 2 over 1? What would that be equal to? 2 over 1 would be equal to 2 wholes, right? And I can divide 2 to help me. So remember that fraction bar is like also saying division. So it's saying 2 divided by 1. What is 2 divided by 1? It equals 2. So it's 2 wholes. Let's do the same thing right here. What's 2 divided by 2? How many times does 2 go into 2? 1 time. That's a really good trick that can be really helpful to us. I also know that anytime that my numerator and denominator are the same, it's equal to 1 whole. So I know that as well, but if I really think of this fraction bar as division as well, 2 divided by 1 is 2. 2 divided by 2 equals 1. So this one represents 2 wholes, right? So let's draw that. I'm going to kind of split this a little bit. So this will be 2 wholes right here. So I'm going to draw 2 wholes, and I'm going to shade them both in, right? Because that's what that means. If there's 2 wholes, there's 2 wholes and they're both completely shaded in. Okay. What would 2 over 2 look like? So we said that it's equal to 1 whole, right? So what that means, and we can look here. So this denominator 1 tells me that there is 1 for like the total pieces. So there's 1 shaded in each hole, but there's 2 holes, right? So this one is telling me that the whole is divided into 2 pieces, right? That denominator tells me that the whole is divided into 2 pieces and that there is 2 shaded in. So I'm going to shade both of these, which gives me 1 shaded, right? Darken that a little bit so I can see that I had 2 holes. So 2 over 2, the denominator tells me that there are 2 pieces in the whole and there are 2 shaded, and that is equal to 1 whole. 2 over 1, the denominator tells me that there's 1 piece, one piece shaded in the whole. So there's 1 piece shaded in the whole, but then there is 2 of those that are shaded. So I had to draw 2. So 2 over 1 is 2 holes, 2 over 2 is 1 whole. So explain, so I do need some words there, the difference between these two fractions with words and pictures. So here's my pictures, I need words. So 2 over 1 equals 2 wholes and 2 over 2, or 2 halves, equals 1 whole. So 2 over 1 equals 2 wholes, which is this one right here, and there's our picture, and 2 halves equals 1 whole, which we have right there. 2 halves equals 1 whole. And there we have it. So we just really need to remember that anytime we see a fraction with a 1 on the bottom, that is equal to that number of wholes. And again, if we think of that division, that will really help us to kind of double check 2 divided by 1 is 2. So anytime we were to see a number with a 1 on the bottom, 12 divided by 1 is 12, 12 wholes. 16 divided by 1 equals 16, 16 wholes. 2 divided by 2 is 1, 1 whole. So think of that to help you. But we also know, we should definitely know that anytime the numerator and denominator are the same, that it's equal to a whole. Okay, that is our lesson for today, boys and girls. So today we really practiced working on fractions on the number line that were equal to a whole, right? And what that would look like written in fraction form. So there it is on the front as well. Okay. Super work today, kiddos, and I will see you tomorrow for some more fractions.